we were going to hit as an industry this same trajectory that of like Moore's law. And I don't mean that in like, oh, the cost of genome sequencing has gone down. It was the tools and the costs of scale and the costs of R&D were going to decrease at a regular enough pace that new applications would be developed, new tools would be developed, and cheaper, 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 and it would be this positive cycle that would just continue. And I think it didn't work on either end.
Weaving like DNA strands on a fascinating roller coaster of endless learning, experimentation, and discovery of technology, where the destination is not the end and the journey is the most fun. This is the Helical Brew. With your hosts, Mike, Sura, Jeff, and Elizabeth.
Welcome, Helical Brew viewers, to episode 18 of Helical Brew. And can you believe it? 18 episodes. We've now kicked off our new series that is focusing on what we're calling blueprints to breakthroughs. So we're looking at technology, the evolution of technologies, and today we have the pleasure of being joined by David Breslauer, founder and CTO of Bolt Threads. We'll hear all about what Bolt Threads is all about, and get some background on both David as well as the company. This is going to be part of our Blueprint to Breakthrough series, episode 2 of that series. We a couple episodes ago we wrapped up our SLAS lead up series, and of course ended with the SLAS episode where we filmed at the show, or after, I should say, right after the show ended, and did a wrap up there. So if you're curious, just dial back a couple episodes to see that. But without further ado, I'd like to introduce David Breslauer, founder and CTO of Bolt Threads. Thanks for coming on.
Yeah, thanks for having me. It's great to reconnect. I know Sura here from having tried to failed to having recruited her a long time ago during the early days of Bolt when we were building out an automation team.
Yeah, well, sometimes it works out, sometimes it doesn't, and you know, I've I've got a couple of stories like that in my past where it was just went a particular direction. But glad, thank you, Sura, for reaching out to Dave and bringing you on. That's great. Well, so this I come from the robotics space, and I was thinking about your company. I did a little bit of research about it, and you know, in when I think about like alternatives to fabrics and a lot of the things we consume, we have polyester, we have cotton, we have all these things we wear, and just materials in general. When I got back into life science after going to the hair restoration industry for a while, I can tell that story on another time, but I was working on a hair transplant robot that was used by hair transplant doctors as a way to kind of allow them to focus on the procedure and less on the mechanics of the procedure. So the best thing a robot can do. When I got back to it, this you know, uh, new synthetic biology, or the new kind of era of being able to create materials, right? With Ginkgo Bioworks, we had Zymergen companies on both coasts that were looking at ways of basically using cells to create material. And anyway, it kind of made me think of that past, and where that's going today with biology. So maybe you can give us a bit of background on yourself and kind of how you got the idea to found Bolt, and we'll start from there.
Yeah, thanks, Mike. So myself, I have a very sort of eclectic background. I am not a synthetic biologist per se, and that's what a lot of people are surprised to find out about me. I'm sort of that's all learned later, and by no means and by no stretch am I a genetic engineer or a metabolic engineer or a cell engineer. My background, my bachelor's was in bioengineering from UC San Diego, and my PhD was in bioengineering from UC Berkeley. Now, at San Diego, what that meant was bioengineering meant physiology and mechanical engineering light. But my interest back then was bioinformatics and ultimately then systems biology. I was way too early in those spaces. I just liked the idea of applying computers to biology. But there wasn't a lot of data in then. It was very much a statistician's game of trying to extract correlations from little data. And so I went for bioinformatics, and I thought, oh, systems biology might have more data. Went to that. Then I got, and this is all going to tie into Bolt. Then I got frustrated with systems biology because I was asked to do a project by my advisor at the time, and my conclusion of the project for mapping this intracellular system was like, somebody needs to do the measurements. So when I went to graduate school, I went to Berkeley, and I was very compelled by the world of microfluidics. I thought microfluidics were really cool. And you probably see a lot of that in your lab automation work. And the reason that was interesting is, one, I was learning that as much as I liked computational work, I just like physical things. I also just like things in real life and making things in real life. And I became very interested in the idea of building microfluidic systems to high throughput systems to generate data from which we could do computational biology, bioinformatics, systems biology. So I thought, how can I bring all these tools together? And so I learned all the tools of fabrication to build a microfluidic device. Now, at the
Interesting. Okay.
time, this was 2005. At the time, bioinspiration, biomimetics was a really hot topic. And my grad advisor had had a big publication because one of his students microfabricated a compound eye. So, a fly eye that has like 1,000 lenses in a waveguide,
Oh, wow.
a microscopic compound eye. And it got a lot of press. And so my advisor said, wow, what can we learn from nature? And he just kind of flippantly said to me, David, how do spiders make silk? And I became very fixated on that idea. And I don't know, something really clicked with me. And the more I studied it, the more I learned. I started reading. There wasn't a huge body of literature back then. It's grown tremendously. But you could see that biologists had really spent a lot of time studying the silk gland, both in silkworms and spiders. And to me, it looked like a microfluidic device. And I thought, well, I could manufacture that device with all I know. Maybe I could make super strong spider silk fibers by mimicking the mechanics of the silk gland. It's, how you process this protein is important. So I dove down. I started designing this device, doing simulations, the whole thing. My advisor's like, whoa, 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 this was a thought experiment. This wasn't meant to be your thesis project. I managed to secure, this was pre-2008, financial collapse, so there was more money. I managed to secure a grant to fund my research. So I became this independent actor, and I built this device, and there was a biomimetic silk gland, but I didn't test it with anything because I just worked on making it work from sort of first principles in terms of the functionality. Stuck my head up and said, okay, great, I need silk protein. What did I know? I literally opened the Sigma catalog and looked up silk protein. I couldn't find it. So then I started diving into the world of silk protein. I started dissolving silkworm cocoons. It degrades the protein too much. Ultimately, to make a long story short, I was introduced to a synthetic biology group, as synthetic biology as we think about it. This was in Chris Voigt's lab at UCSF, so right across the bay from UC Berkeley, who was working on engineering a recombinant microorganism to make silks. Specifically, they were working on secreting complex proteins. They decided to demo it with silks. They got extremely frustrated on why silk was breaking their system and became more obsessed with silk than their system. I met the graduate students, we hit it off, and we started meeting regularly to talk about silk and silk science and silk proteins and protein materials and all the cool things they could do. until ultimately, and this was back in the day. I say back in the day because, 15 years ago, but a lot has changed. Back then, the
Sure.
only way to start a company in biology was to have a PhD and get an SBIR. Now you can get seed grants across the board, but we decided to write some grants together and see what would happen. And we wrote grants saying we're going to make spider silk and kind of figure it out. And maybe we'll make bulletproof vests. We don't know. Maybe we'll make textiles. We don't know. But we got our SBIR and then got started. And that's how the company got started.
Fascinating. And
That's
that's got
so
to be the coolest synthetic
Yeah.
biology story
that's a
I've ever
great
heard.
bucket.
Yeah.
Yeah.
And since then I've become more of a, I still wouldn't call myself a synthetic biologist, but I come in the classical sense, become more of a synthetic biologist. I'm really a protein materials scientist or engineer, more than anything.
Yeah. But to be able to go, yeah, to drive into the space in such a cool way. I mean, because you hear about, okay, we're going to do alternatives to perfumes and scents and all these things we heard about early on in synthetic biology. This will be our future factory, right? And some of those models
Right.
just didn't collapse. I mean, you're talking about real practical things from day to day life that you can, and silk is such a key part to so many things. And so, yeah, that's really fascinating. And so
Well,
when you
I think,
founded yeah, uh-oh,
Mike's cutting in and out a little bit, but I'm
okay.
interested to know so at the Enzyme Engineering Conference that I was at a few years ago in Vancouver, I met Chris Voigt, and he's great, and him and his grad students are doing so much. How did you connect with him for this project?
I mean, there was a lot of serendipity. Everything through Bolt's Series A financing is like a fairy tale. After that, it became Silicon Valley crazy. After that, it became like classic startup struggles. After that, it became, same failure modes as all industrial biotechnology companies. But through the Series A was this fairy tale. So, I mean, I told you this story, and that's not embellished. I was out looking for silk protein. I had spent all my time looking at the literature on materials processing, started digging into the literature on natural silks, just could you dissolve spider webs, as well as genetically engineered silks. And I had one professor, actually the dean of engineering, just said to me, hey, there's a guy at UCSF. So Chris Voigt was giving a talk at Berkeley. I saw he was giving a talk, so I went to the talk. He talked about the spider silk work. He held up a vial that
Wow.
looked like a couple grams of protein, and I went up to him and I said, "This is what I'm working on. This is why I need that protein." He said, "That's super cool. I can't give you this. This is my demo, but let me connect you to the grad students working on it." So he connected me to the students. Um, Actually, sorry, there's more to that story. He said, my students will give you some of the material. And a month went by, nothing. 2 months went by, I pinged him, nothing. 3 months went by, he's like, oh yeah, I'm sorry, I'm busy. Eventually he said, look, we're having trouble getting the material, let me connect you to the students. That's how it happened. So he connected me to the students, who ultimately became my co-founders, and they said, oh man, that vial, we've since learned that it's mostly salt.
Oh,
Like our assays were not good enough, and silk has completely confused us. It's messed with all our analytics, everything. We're still trying to figure it out. But like we don't have what we thought we had. So but we kind of clicked, like me and those guys. So it was just like, oh, okay, let's just keep talking because silk is annoying. And how do we, but we're fascinated. Let's try to make it work. So it went from there. And, the reason I say it's a fairy tale is because we got the SBIRs from the National Science Foundation. We started working in a lab called the QB3 lab. Now there are a bunch of biotech incubators, but back then that was one of the few in the Bay Area, small lab. And because it was one of the few, investors would walk through it frequently. We were introed to an investor who was very interested in us, who helped us refine at least a potential business plan because we still hadn't made the material to the point that it made sense to pitch his partnership. And he funded us, and that was Foundation Capital, and that was like 2011. And so we spent a year in grad school planning the company, a year doing work under government grants, and then got venture capital.
Well,
Very cool.
quite a story,
Um,
I have to say.
so, okay, maybe tell us a little bit more about what was the story you were telling your shareholders early on in terms of where you wanted to take the company, what industries you wanted to go after. What was the business case, the first initial business case? I've been at a startup where we pivoted twice from the original business case. So, yeah, what was your original case?
I
Oh yeah,
remember Kevlar being a thing.
it's been a long journey. So when we wrote the government grant, we pitched, ballistic protection, which is the fancy way of saying bulletproof vest. That's historically what everyone has talked about because spider silk has gone through many cycles of people trying different production hosts, including pygmy goats, E. coli, then yeast, then pygmy goats, back to E. coli, back to yeast. As the technology has progressed, in terms of people, a lot of people did tobacco plants for a while in terms of trying to make silk. And everyone's like, if we can make super strong spider silk, we can make a bulletproof vest. And the Department of Defense had a spectacular investment and news and then failure with the goats. The first Canadian public biotechnology company called Nexia Biotechnologies. And, they had trouble with the goats. They didn't make much silk. The silk bound to the fats, and they were difficult to purify. The long cycle time of the goats. It ended up, ending in bankruptcy. But we found some of their old business models, and it all made sense if the material worked to spec. They were talking about fishing lines that's biodegradable, bulletproof vests. So we followed that same example. That's how we got government grants. As we started talking to venture capitalists, we realized when you start digging in, it's, the government procurement process. Most procurement processes did not meet a venture capital timeline, let alone a government
Sure
procurement
not.
timeline. So we were trying to figure it out. And we ultimately ended up pitching because what we believed, we were very convinced on, and is that there are an abundance of materials. There are rubbers in nature made out of proteins. There's chromophores. There are so many functional materials, sensors, things you can mix and match and assemble and make all these phenomenal materials out of. We're like, this is a platform to make a lot. And our first angle was, ultimately what we realized is, in order to get to super strong silk, just to even make enough of it to test in an application, you're going to go through a path that's going to make textile quality silk. So we said, what if we just tried to make commodity silk and see if we could make it with better consistency, quality, make it washable because we could engineer the protein in ways that had value add for the apparel industry. And so that's what we ended up pitching, that would be our market entry, better silk. Vegan silk was actually a topic at the time. And silk was reasonably $80 a kilo and getting more expensive. So that's still cheap for a biotech product, but it was expensive relative to other, materials. So we thought, let's enter the market there. There's a lot of ways I would, in now my much more experienced wisdom, challenge that and say that was naive, but that's how we started. And we were going to pivot through there. Now, the story of Bolt is, to your question about pivots, is interesting because while we started there and said, okay, we're going to sell silk, we're going to sell silk fibers into fashion and apparel. And by the way, when we wrote our NSF Phase 2 grant, which we ended up getting, that's for much more money, I was just I felt so self-conscious submitting a proposal saying we're going to make textiles for clothing. But they respected our business model, our business proposal enough that shift wasn't so absurd. Corning's actual first product with one of their glass fibers, or first demonstrations, was a glass fiber tie, and one of our first products was a silk tie.
Yeah.
Wow.
Yeah, but so we
I remember the
kept
promo.
pushing pushing on making these fibers, and eventually we started talking to apparel brands, big sports brands, and it felt like we might be able to pursue a more pharma-like model, which was we will end up in a development agreement where they help fund a material development. Rather than us trying to make a material and sell it, they will fund the development of a material and buy it. We kind of, I don't want to say we pivoted, we just kind of started focusing on what is the partnership, what is the partnership, what is the partnership. Now, the feedback we ultimately ended up getting over all these years of making this fiber, trying to figure out what people want, one, it was very frustrating. A lot of people just said, we want cheaper wool. But then two, a lot of people said, we don't have, your fibers are cool. We don't have a fiber problem. Like, you're not solving a problem for us. You're just showing us something cool. We have a leather problem. We think leather is, going to go out like fur. Now, ultimately, that did not turn out to be the case, but at the time, that was sort of the concerns of the execs. Leather's going to go out like fur. And what we had both had done well was make sort of beautiful things out of biomaterials. We had shown a Stella McCartney dress. So I think there was a sense from executives at these companies like, you make pretty things with biomaterials. You're not just coming to us as engineers. Like, you seem to have a sense of aesthetic. Can you make a leather? A leather? And so that was a very hard pivot for us. We started focusing on what could we do to make a leather, and that was a whole different technology platform. We learned about mycelium. We played with it. We said, this is going to make a better material than if we tried using silk or recombinant collagen or anything, and went hard into making mycelium leather. And that was extremely popular. And that was our sort of our breakthrough focus for a long time. What was wonderful about the product and the fact that it was biomaterials, unlike pleather, vegan leather, just plastic leather, it was breathable. It had the aesthetics of leather. It aged like leather. But what we kind of unintentionally fell into is that suddenly the technology was such that it required more manufacturing than we had anticipated. It required us building multi-million-dollar facilities. And whereas that we just kind of accepted that was part of the plan because there was a lot of interest and momentum, when the interest rates spiked several years ago, suddenly that was no longer an acceptable plan. And whereas the demand was there, it was not sufficiently there to justify a return on investment for continuing that. So, like everybody else, we had to do a massive layoffs and figure out what we were doing going forward. And
that's what we call the rise and fall in Mylo, care. Right?
Sorry, what, Sura?
That's what we call the rise and fall of Mylo, because everyone was so excited when you and other people started investigating it, and this is going to really change things, and we won't be like slaves to animal products, right? And it just kind of went downhill as soon as the economy shifted.
Yep, it broke my heart. It was illuminating in that at the point of desperation, when we were looking to figure out is there any way to rescue it, it felt like the industry was nowhere to be found financially. The fashion industry wanted it, but was basically like, we don't invest in materials. And the material manufacturers said, we would love to supply this, but the fashion industry has eked us out on all margins, so we have no money. I'm not pointing fingers. Of course, there's bigger dynamics than that, but it was kind of like everybody was willing to go along with the trend and the enthusiasm, but when it came to actual money changing hands, at least I felt kind of left out to dry. Like all the partners were there until suddenly we weren't subsidizing everything anymore. And then it was a very quick disappearance. But I will say, for any of those listening. The individuals who were working on these at every big company they were good. The groups that we partnered with at the major companies, they all wanted to affect change, but it's really hard to change them, these massive organizations who are built around supply chain optimization and cost reduction. So I don't want to demonize those individuals in any way. But it was hard. It was hard.
Is there a scenario where that could come back, set of business conditions where it could be viable again, or just kind
If
of,
we still have the IP, we
yeah,
still have the material. We continue to explore it, explore what possibilities there are. But we will see.
for now it's going to sit on the shelf and
Yeah.
hey, I mean, fusion, right? Constantly comes off the shelf,
Yeah.
try some things and put it back on,
Well,
Uh,
I mean, that leads to where we currently are. Honestly, it's
right.
for the longest time we had been every year or so we played with the idea of what are we not exploring, and we had a number of different proteins that we had made, a different materials that had different qualities, and we dabbled every now and again in personal care because we thought like, okay, well there are margins there, but we never wanted to be an ingredient that was only a gimmick or only a story, and we never found something that really felt impactful. We were not interested in trying to start a brand just so we could say like spider silk on your face. That wasn't
Yeah.
our thing. Um,
Although that's a catchy gimmick.
it is catchy, but we were, we were technologists in that we wanted technology that did something. And maybe that's dumb. Maybe that's why, we would have been more successful business people if we weren't if we weren't trying so hard to be technologists.
Yeah.
But we dabbled a lot in personal care, and at one point we thought we had an ingredient that would be have a really cool function, and we started testing it out and kind of accidentally discovered that one of our silk proteins was giving two things. One, a beautiful aesthetic to formulation. So the sensorial attributes, the way it feels on your skin, the way it dries on your skin, was basically the equivalent of a silicone elastomer or better. Now, silicone elastomers are in all your personal care next to skin products, and they're getting banned in the EU. So people are scrambling into figuring out how to replace them because that's what makes everything feel so good.
Yeah.
You want to use it because it feels good on your skin. The good sunscreens have this stuff. If now they have to replace it, what do? So it's getting banned because it's bioaccumulative. It's extractive and bioaccumulative. Huge power consumption to make it.
Mm.
And we stumbled into the fact that we had this alternative. Then turns out that also our ingredients, we could design them to be film formers, to be skin penetrative or hair penetrative. And suddenly we kind of, as we opened our eyes to a different industry that we hadn't paid a ton of attention to before, we realized we had a lot more capability to engineer into functionality in sort of both active and passive properties in personal care than we had in fibers. It was a lot easier. The cost basis worked better, and it's an industry that's much more competitive and adept and open to innovation. They have a very different cycle time than apparel, and they're more interested in durable, effective innovation, whereas fashion and apparel are more interested in storytelling innovation.
Sure. Well, it's also it reaches so far through so many industries, right? What you're just describing, like the sunscreens, all these different, places where these materials are used. So that makes a lot of sense.
Yeah. So our current materials we've got two materials on the market, Beak Silk and XL Silk, both recombinant spider silk based polypeptides, Bee Silk spider silk based. And we make them metric ton order of magnitude capacity.
Wow.
And yeah, we're selling them into the market, and the reviews so far have been fantastic. You can buy products with them now. Lady Gaga just launched a mascara with Bee Silk called her Bee Structural Mascara with House Labs. I've worn it, but now have not put it up to a battery of tests because I don't really know how to evaluate mascara. Um,
Sorry. Are you wearing the mascara?
I'm not wearing
The
if I'm
viewers want
wearing
to
the
know.
mascara, you'd know it if you've seen the photos. But people swear by it. There's something amazing about the ability to of these materials to be versatile. Their versatility, both in terms of how they can formulate and then adapt and then lay down on your skin or your hair and interact with your biology in a way that other materials can't.
Yeah, and that's really to me. I mean, yeah, you had to sort of bounce through different stages and pivot a couple of times, but to me, it sounds like yeah, where you've arrived is the perfect scenario. Being somebody who's been in the OEM part of robotics for so many years, right? We're not the full solution, developer. I mean, that's where things begin to get more niche, right?
Right.
And fashion, I can imagine, very niche. Very subjective. There's a lot of aspects of fashion and the decision making when you get a room full of designers in talking about things, right? They might be like my engineering mind's like, oh, that's a great idea, I love this, and they're all like, no, 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 it's never going to play. And here, it could be a back end technology that enables customers, and that's the position I always like to be in. Sounds like you're in a similar one,
Yeah,
to
no,
enable
it's
your
very,
customers.
very exciting. People are very into the idea of, taking from nature and looking at nature, understanding what evolution has brought us and capabilities it can bring. As someone who's been, since 2006, just like seeking a world where we can start really playing with what are those cool materials out there. Like, dragonfly wings have a protein called resilin that's one of the most efficient rubbers ever measured, 98% resilience. And, we made it in lab, and you can crush this thing down nothing. It springs right back. We haven't found the exact use case for it. At one point we were looking at, shoe soles, but it's got some other problems that don't make it amenable to shoe soles. But it's like, now I'm starting to see where all these things can at least find their first launch and market, and some pretty incredible use cases. You're not going to harvest dragonflies. There's no other way to get this material except from microbial engineering.
Wow. That's super cool. Well, I mean, the sky's the limit, right? You've found some ways to to create materials in a lab and bring them into production. Is the production part? I mean, is it sort of a project you start looking at early in the process, or is it you kind of work through the material thing and then look at how to
There's
produce it in mass?
it's a good question, partially because it's a real chicken and egg problem, and I don't think there's a good solution yet.
Okay.
Which is particularly for materials that you make with biology. It's hard to synthesize and expensive to synthesize the material in any large amounts. And so you kind of design a couple, put all this money into, unless you're measuring microgram quantities, then fine. Put all this money and time into generating gram scale, 100-gram scale quantities, only to then say, okay, is this the right material? How do I need to change it before doing the scaling up? And it's a difficult cycle. I've been trying to solve this one for a while. I mean, there are some obvious answers that would require millions and millions of dollars of R&D. So it's hard to justify the ROI up front, to ultimately say I have a platform so that I can iterate quickly with large volumes of material. But I don't yet know what material I want to make. It's a hard proposition, and I've been trying to figure out how to solve that one for quite some time. And I don't just mean solve it technically; I mean finance it,
Sure. Yeah.
because in an ideal scenario, any new material with any arbitrary level of complexity in a protein, you could say, I can make a number of them, and in a few weeks, a month, I can have several grams of each, and the materials engineers can play with it, the product developers can play with it, and then we can go back and cycle again in a cost-effective manner.
Okay.
But that's the problem. It's real expensive to do
I
right
bet.
now.
That's what I was thinking. Yeah, because the different, like you were talking about leather earlier, talking about silk. I mean, I was coming up with the different textures, right? The different how the material, how you're creating the material in a large capacity production environment. Imagine that's very different, and a whole R&D process all by itself,
Oh yeah.
just to
Oh
figure
yeah. I
out
mean,
what that
the
looks like.
manufacturers we use are, fermenters 5 stories tall, things like that, huge production scale, huge volumes of raw materials, but it all starts, in a little vial.
Yeah.
Speaking of the
You
vial,
can't do product development with the material you get from a little vial. You can do analytical science. You can't do product development for consumer materials. And so
Yep.
figuring out the Venn diagram there is a challenge.
You're gonna say
did you
something, sir?
ever, yeah, did you ever, speaking of the vial, when you were looking at Chris Voigt holding this vial of spider silk in front of the audience, did you ever imagine the path that would get you to working with, fashion folks like Stella McCartney and Gaga promoting your like materials? Did you ever imagine that path when you were,
I
thinking
mean,
about like how do I make more of this and how do you go after that?
after we raised VC money, like we kind of Dan and I would fantasize. We had big visions, like one day all the people on the runway will be wearing stuff with our material. But really, no, I had no realistic expectation that I would literally go to Paris Fashion Week multiple times, and I would literally like Lady Gaga would wear and promote our mascara, talking about the material I invented. That is not that was never in my conception whatsoever. But
So
it was
cool.
exciting. It's grateful. Like sometimes I often forget it, and it's a good reminder. It's like, oh yeah, I've been to Paris Fashion Week. I'm like, we made materials that walked the runway. Like
Yeah.
that's cool.
But that's so great to like go from this like passion for the science, and finding these things in nature that can actually benefit, what we use on a daily basis to all the way up to like how it's impacting society and how people are, really playing into it and exposing it and making it trend in a way.
Yeah, I do think that there's something fundamental here. Like when we talk about industrial biotechnology and materials, there will be at some point a fundamental shift in terms of the kinds of materials we can make and people want. I think we're still early in days in terms of our ability to hit economics quickly and find product market fit cost effectively. You know, part of the Bolt's generation when we started in 2010-ish, we're coming off the tails of the Amyris generation, which was focused on how do you scale Amyris, Geno, Solazyme. And so they put a ton of money into scale. And so the big lesson coming out of that was you can do great science, but it's really hard to do scale up. So, be very conscientious. Don't pick a market that requires you to build your own fermenters. So, we come out of that lesson going like, okay, we can use contract manufacturing for fermentation. We'll need some small spin lines, extrusion lines to do the fiber spinning. I would say one of our learnings is it doesn't matter if you're building a $100 million facility or a $10 million facility. Do not run manufacturing if you don't have to. Like, it's hard. It is hard to do that. Find partners, no
Yeah.
matter how much VC money you have. Like just because it's an order of magnitude cheaper does not mean it was any easier. But I think really the enthusiasm at that stage, the expectation, and this is when Ginkgo was starting and Zymergen was starting, before a lot of the pivots, was that we were going to hit as an industry this same trajectory that of like Moore's law. And I don't mean that in like, oh, the cost of genome sequencing has gone down. It was the tools and the costs of scale and the cost of R&D were going to decrease at a regular enough pace that new applications would be developed, new tools would be developed, and cheaper, 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 and it would be this positive cycle that would just continue. And I think it didn't work on either end.
Hmm.
Couldn't like the tools didn't get cheaper fast enough. Tools did get cheaper, but not cheaper enough. And then also we didn't find the applications quickly enough. And we didn't find the right applications or the timing wasn't right. You know, it depends on the industry you're looking at. I mean, plant-based foods or precision for like that whole industry, you know, it's not clear where that landed. Like, you know, it's not doing well. And, you know, is that ever going to come back? Was it just a fad? What happened? You know, Impossible Foods making heme that was like blood. Like, does anybody care anymore? I don't know. But at one point, people really did. And it felt like people were willing to pay a little bit of a premium. Um, would it have been better? I don't know. I don't know. So that didn't that belief has not yet panned out in a way. And so this is why you're seeing like another generation that will likely spring up of companies when, you know, AI makes it all cheaper, that much more understandable, et cetera, et cetera. But that was that wave was like, no, this is the time that it's going to work. But biology has managed to continue to elude us in devilish ways.
I was wondering, guys, when that was going to come up in the podcast. Forgive me, David, because AI has come up in like 3 of our podcasts so far,
Yeah,
and
just
you've
keeps
taken the
coming up.
lead.
Well, I don't want to. I think what's interesting. I dabble a lot in AI tools for a variety of different things because without being sort of a pitchman for AI, like AI is not my thing. Like it's tremendously useful across a lot of different areas. If you talk about AI for new materials, AI for like I'm not pitching you I have an AI solution. I do use a lot of LLMs and LLM technology. I follow it because I think what you're seeing or what we are seeing, and it hasn't been proven out in the lab just yet or commercially just yet, but the capabilities to reduce the experimental search space to find a hit are getting so much better. Our
Yeah.
ability to design things that might have been counterintuitive for us to design based on our learnings. You know, the stuff that's coming out of David Baker's lab, and the ability to just say, this is the shape the protein needs to be. Design me a handful of shapes that fit that protein. You can call it AI, you can call it just sheer brute force computation that's just gotten better, whatever words you want to use. There's something there.
Yeah.
It's not the whole panacea. It's not going to solve all our problems necessarily, but it's going to enable it's either going to enable or lower the ceiling from to make it much more accessible in terms of cost effective to get answers or get to where you need to be. And then I do believe, and this is more philosophical, when you look at these protein sequences and genome sequences, the way in which we tend to read them as humans and describe them in text as sequences of letters, when really in nature they interact more fluidly as overlapping sentences and knots and strings. LLMs are just much more amenable to that broad context of that entire sequence, whereas we tend to try to segment things, and that was the history of synthetic biology. It's like, how can we segment these and block them up so that we can make it understandable like electrical engineering? And I think biology, frustratingly, has a lot more complexity and nuance and second order effects and multiple interactions, and it's just really hard for us to conceptually decipher. And these LLM tools are just much better at it. I mean,
Yeah, there's definitely a massively parallel capability that comes with LLMs and the processing power and the way LLMs are applied to a particular problem, even something as simple as creating an image from nothing, right? It's using a massively parallel data set, analysis and processing of all that information at once,
I did
that
not.
a human just can't do.
As a
Yeah,
non AI person, I underappreciated the capabilities of generative AI.
yeah.
I did not expect basically a trained model was saying fill in the blanks to make. I mean, and maybe it's because I was overtrained on autocorrect or autocomplete. Like, it used to be like you could jokingly make a story by just auto completing, and it
Yeah.
was so bad. The fact that AI can write a whole essay that makes sense, like, yes,
Yeah,
it's got its flaws, but it's comprehensible and it makes sense. It's like I really underappreciated the fact that fill in the blank essentially could work so well. And that also applies to, these protein language models and these DNA language models. You train it on every protein out there and you just say, okay, these things make these structures, fill in the blank and tell me what it makes. And it's like, it's not nonsense.
yeah.
And we have to validate these things experimentally, of course. But again, the number of things we're going to have to validate to get good data is dropping. So
Yeah.
that's my
I
take.
appreciate that.
My nuanced take on the potential of AI. I mean, I use it a lot for literature searches and literature analysis because the field I am in, silks and protein polymers, very scattered. People use different terms, no structured data. It's
I
all over
like
the place.
that.
It
Yeah.
is. Some people say silk, some spider silk, protein materials, recombinant silk. It's just searching it is a mess.
Yeah. Yeah. And image analysis is another area, in life science that we've seen, the use of AI,
Oh
where
yeah.
you're doing many, many images. You can look at them all at the same time and then use that information in parallel for new problems. A friend of mine's daughter actually wrote a whole piece on using, AI and a big database of imagery to predict breast cancer way earlier than is even possible with a
So
human looking at the image. Yeah.
when I started in my graduate program, there was a huge computer vision program within our department in UCSF, and I always thought it was interesting, but never drawn to it because it felt like okay, not enough data, trying to cover statistical algorithms to get some statistical significance. What I did not appreciate, and what I sort of see now, and this is because of AI and all this, is really like the fact that if you have enough data, like if you really go at a massive scale data, you can, with these new models, you can get very comprehensive answers. And I just like, for me, I just didn't appreciate. It's like you can have a relatively simple model, and if you train it on the entire internet, it will talk to you. Like, like the fact that it was just like, okay, if we just scale this up from training it on like a PDF to a book to the entire internet. It will talk to you. If we just feed in massive amounts of radiology data, it will figure it out. I mean, I saw
Yeah.
recently that some AI computer vision was able to discern a person's sex based on a photo in their eyes, and doctors still don't understand what it's doing or how it knows. And then I saw someone recently tweet right after that their technology has the ability to look inside the LLM's thinking process, and they were able to suss out what it's seeing. I mean, again, all of this is
Wow.
happening so quickly.
I'm
You
gonna
could just
cover
literally
my
sit
eyes
on
for a
Twitter
bit.
all or X, whatever they're calling it, just all day, just like what is the latest.
Crazy.
That's fantastic. Well, yeah, and the stories like that, I think, are ones they can start working with immediately. It's not like you have to found a whole company around
Oh
that. Something
yeah.
they can apply in existing companies that are already doing the image, getting the image in, taking the images. We're not having to build a huge piece of hardware. It's just how do we use that data in a better way, and make the tool, many, many times more useful. I thought I'd switch gears a little bit and going back to Volt. And what do you see? What's in the pipeline for Bolt? What's next now that you've got this production and you're supplying to Lady Gaga and your other customers
I know,
for
right? I'm
their
still waiting for my Mylo bag, but
Well, that's going to take a while. Um,
were there any prototypes ever made?
oh yeah, we
Yeah,
have. I
yeah.
mean,
they had a cool
my
like
wife has
campaign.
a Stella McCartney
Whole
Milo
product line?
Colabella
Okay.
bag. No, no, we made product.
Yeah.
Yeah.
Um,
Okay.
um,
Got it.
um, in terms of, so our emphasis is on, right now we're really focused on sort of selling our existing molecules, and because we're doing some early stage R&D on other stuff.
Hmm.
But the reason I emphasize that is we still have not remotely tapped the versatility of our ingredients. Like, these materials can do so much, and we keep discovering more and more and more and more ways in which, you know, these incredibly versatile silk-based polymers can just be processed in different ways, formulated in different ways, can be used. Again, we are in hair care, skin care, mascara, like color cosmetics. We just keep learning more and more and more in different ways. This material, it's not a one hit wonder. It's not uniquely suited, or exclusively suited for skin. And the more research we do, the more benefits we discover, and we continue to roll out new products. And I think that's sort of the name of the game right now, is more and more products with our ingredient in it, such that Bee Silk becomes a household name.
Do you see it continuing on that ingredient pathway as opposed to what you were looking at before, materials, or are you maybe that?
Well, I use the word in materials and ingredients somewhat interchangeably,
Okay,
because it's an ingredient in a formulation,
sure.
but that's what that industry calls it. They call it an
Yeah,
ingredient, whereas fashion calls a fiber not an ingredient; it's a material.
material. Yeah.
I look at it as a material because if you look at bee silk under the microscope, it's actually a hydrocolloid. Both bee silk and XL silk are hydrocolloids under the microscope. So I think of it more as a material than an ingredient.
Hmm.
Partially, it's a polymer, and it's a folded polymer. With interacting with other silk molecules. So as a material scientist, I think of it as a material. Um,
Got it.
that's why I call it interchangeably.
I got you.
That's pretty
Yeah.
cool. So we didn't warn you,
Mhm.
but at the end of the podcast, we like to do like a pick of the week, which might
Okay.
be tech, which might be a book, which might be anything that you can imagine. Mike and Jeff always have something, so I'm just gonna throw it out there. Do you have anything you want to share for a pick of the week?
I'm sorry.
You
I
blindsided him, sir.
Being blindsided. Yeah, it's so what we it's like and Sura's done books in the past. We've had guests, or anything you're reading, you're listening to,
Oh,
or tools you're using. It could be a specific you know tool of generative AI that you're using,
okay, okay.
things like
That's
that. But just what's catching your eye, and
um.
something that's helpful. Mm.
No pressure.
Yeah, I am currently very into AI based application development. And what I
Okay.
mean by that is there's a bunch of tools out there. I recommend looking at Replit, where you can literally go from prompt to app, like just build me a mobile app that does. And
Wow.
the things you can do, build me a mobile app that's a grocery list checklist that has a specific section for my kids' foods. The things you can do are quite extraordinary, once you can just sort of state the problem you want to solve, and suddenly you have an icon on your screen that does it.
What's
Um,
Wow.
David? How do you spell that? Sorry.
Replit, Replit.
And we'll link that in the description later.
Yeah, that is my. They just released, I think, the end of last week or this week. They could make it could make a mobile web app or a web app. They just released straight prompt to iOS or Android full app
Wow.
tools, and
That's crazy.
it's
Software
a
engineers,
brave new world.
beware. It's
Yeah.
coming.
I mean, yeah, no, it is a brave new world. I don't know. I sometimes get stuck. I'm like, I don't even know what to build.
But see, that's what AI is supposed to do, right? It's supposed to unleash the human creativity, but then you're like, well, I don't know what to tell it.
I mean, eventually it'll just be like, I see you're having a problem with. Here's a solution for you.
Yeah, yeah, right. My phone's just going to listen to me and figure out what I need, and it'll be on the screen when I
It's no
charge
longer
overnight.
product recommendations. It's going to build a product for you. Oh, I didn't
There
know I
you
needed
go.
that.
That is exactly what you needed.
That's awesome. That's awesome. Well, I'll go next. I have, Jeff knows and everybody knows I have a lot of microphones, right? Which mine that I was going to use earlier today didn't work that well. But I also like headphones and headsets, and so I've gone very old school with it's essentially an aircraft headset that has been adapted to just using the same cups and the same noise insulation as you would use in an aircraft headset passive. So the reason I'm using these though is I found that I on long flights I'm actually I like the noise canceling for listening to the movie. It's not so great for sleeping.
Right.
There's that sound and there is a sound pressure even though it's making it sound like nothing is around you. It's doing that with opposing sound waves that are still hitting your eardrum in an ear cup. And so these are totally passive. So I've gone with something more, just essentially feeding a little white noise or brown noise into the headphones on a long flight just through the regular cable. It's nothing special, not wireless. Um, and I find that I'm in better shape after these long flights than I would be if I had the big Bose noise canceling. I'm maybe not so for everybody, but yeah, these are, you know, I get questions sometimes when I'm on the plane. Are you going to be flying later?
That's
It's
funny.
something like it looks like straight
I
out of
was gonna
Magnum
say.
PI. What TC would wear when he had the helicopter on. It's probably the most commonly used brand of headphones when you see an aircraft in a movie or television show.
One of those
But yeah,
pictures sorry, Mike, one of those pictures you had posted when you were flying out to SLAS, you
I
had
had
those
them
on.
That's right.
And I was like, is he listening to the cockpit recording through FlightAware or something? What's he doing?
Yeah, and what's also cool is they have a volume knob where if you want to cut the volume on one ear cup and just listen out of one ear or something like
Old
that,
school knob, even.
you can do that, right? Yeah, no, it's old school, but it actually has a 3.5 millimeter jack on it, which seems like no product these days wants to support anymore. So I have to have a USB adapter, another dongle for an Apple product. I love you, Apple, but you're the dongle kings of the world. So, anyway, that's my pick. Jeff, you got something?
Well, not really. I was just
Okay.
kind of thinking, I've got something over there, but it's in a, I'd have to unwrap it. It's a pain. I'll do it next
Next
time.
Next
week.
time.
Next week.
Next time. Yeah. Well, where can listeners learn more about Bolton and
Yeah, you
yeah,
can go to boltthreads.com and learn more about Bolt. You can buy the House Labs Be Structural Mascara.
there we go.
More products have Bolt Bee Silk in it, and Freaks of Nature sunscreen, and a lot more coming soon.
Oh,
Do you have a
nice.
That's a
full
great
list that you
name.
maintain on your website of products
We are
for
updating our website currently to have the full
Okay.
list. If you
Okay.
Buy the
follow us
mascara
on
and
social,
be
you'll
friends
find
with
all the
Gaga.
latest.
That's cool. That's cool. And you're not getting like phone calls from a guy named Peter Parker from Queens
No.
asking about silk.
We did have a history with Stan Lee when we launched the tie. We sent him a
Oh,
tie, and
really?
yeah, and his Dan, my co-founder, sent him a nice note and sent him a tie, and his agent called us and said Stan expresses his, appreciation. Spider-Man,
So
Peter Parker
cool.
was his favorite character. He thinks this is really cool. So yeah,
That's
if I
that's
recall
awesome.
correctly, Dan even got a call at one point randomly, and it turned out to be from Stan Lee. And it was just, very just like, I just wanted to thank you. I like
Wow.
Spider-Man so much.
That's so
All of
cool.
us comic book fans, so much enjoyed what the Marvel, the most recent, Marvel Universe writers, writing stand into pretty much every movie.
Yeah.
Uh, that was great. Well, fantastic, David Breslauer.
Yeah.
Making sure I got that right. Just testing myself here as we wrap up the podcast. Thank you very much for joining us, and what an inspiring story of your company and the journey you've been on. Thank you for sharing that with
Oh,
us.
thank you.
I think listeners are gonna tune in because that is, for a lot of us. I'm not a biologist myself. I'm a roboticist. I got into life science. I got, my passion is supporting the industry, right? With this, you focus on the biology, we'll focus on the automation and doing that right and giving the industry better tools. And I think you're giving the industry better tools. And so it's great to see a success story in synthetic biology. Because, like I said, when I started back into this in like 2014, that's when these companies, I remember the Amyris and Zymergen, right, were really making the press a lot. And yeah, it's like you said, it's, well, the production thing. What do we do there? So finding getting into that stride where the production isn't getting in your way is maybe that's the holy grail of the industry.
Yeah, we're all still figuring it out.
Yeah. No, I imagine that's true with so many. Like I said, biology is just more complicated than
Yeah.
it might appear, right? When you have to look at it in a kind of a parallel way. And so, thank you very much for coming on and sharing that journey. For listeners, more information about Helical Brew, and you want to check out our YouTube channel. It's at www.helicalbrew.com. Of course, we're always publishing to Spotify, and that gets republished over to iTunes in audio only. So you can dial it up on your RSS feed podcast listening tool as you want. And yeah, please like and subscribe. The YouTube's probably the easiest way to do that. Just go to our website, helicalbrew.com. That'll take you to the YouTube page directly. You can like and subscribe and get automatic updates of when we do a new episode or a new short, as we've been doing lately with Sura's work. Thank you very much. The shorts have been really great, highlighting our different episodes, doing previews of our episodes before we kick those off. So thank you again, and from all of us at the Helical Brew crew, episode 18 is in the can, and we're looking forward to seeing you next time. But for now, we're out of here.
Thank you for joining us on the Helical Brew. We're glad to have you with us. For more episodes, please visit our website at helicalbrew.com. That's helicalbrew.com.